Good morning, student. Yesterday we have seen about scattering of light. Before that, we have seen reflection of light, turning back of light in the same medium. Next, we have seen refraction. When light passes from one transparent medium to other transparent medium, it bends. This is called refraction. Then next we have seen dispersion. What happens in dispersion? Dispersion में क्या हुआ था? The white light had been split up into its constituent 7 colors. That is violet, indigo, blue, green, yellow, orange, and red. From that, we concluded that white light consists of 7 colors. That clear? Okay. Next, we have seen scattering. When the light travels through the air, what happens? It strikes on the particles in the air. When it strikes on the particle of the air, it will absorb the light energy. It will absorb the light energy and remit it. So that the straight part of the light will go on changing. The light is travel straight. When strike it on the particle, क्या होगा बोलो? उसका path change जाएगा. So this phenomenon we called as scattering of light. इस phenomenon को क्या नाम दिया था हमने? Scattering of light. है ना? Then during scattering, the white light consists of 7 colors. All these 7 colors are scattered. All these 7 colors are scattered by different particles. Smaller the particle, it will scatters light of smaller wavelength, that is violet. Okay, larger the particle, it will scatter the light of larger wavelength, that is red. Okay, so in that way, violet, indigo, blue, green, yellow, orange, red will be scattered. Okay, so air molecules are very smaller, oxygen, nitrogen, carbon dioxide, so they will scatter. They have tendency to scatter the shorter wavelength. Which one? Violet, indigo, blue, green, and yellow, and like that. So shorter wavelength is scattered by smaller air molecules. So that we have seen yesterday. So oxygen, air consists of what? Oxygen, nitrogen, carbon dioxide. They are of small size molecules. That's why they will scatter the light of smaller wavelength. Which is the light of smaller wavelength? It is VIB. This light has smaller wavelength. Then air also contains water molecule. Water molecule H2O, 2 hydrogen, 1 oxygen. The molecule size is larger. Then what? Smoke, dust. All these molecules are of larger size. So they will scatter the light of larger wavelength. What about light of larger wavelength? Which is the light of larger wavelength? It is yellow, orange, and red. The red is the largest wavelength. So possibility of scattering the color violet, indigo, blue is more than the red. Okay, so this is what? A reverse order that we have written, VIBZYOR. Which is scattered more? Violet. Which is scattered least? That is red. Okay, so this is our Mother Earth. It is surrounded by atmosphere. Now atmosphere near the Earth is denser. As we go up, the atmosphere becomes rarer and rarer and rarer. Up to 400 kilometers from the Earth, there is atmosphere. Okay, and Sun is just below the horizon. So light from the Sun will enter into the atmosphere. When it enters into the atmosphere, it suffers from refraction. It suffers from refraction. It bends toward the normal and go on bending and finally enter into your eye. You are standing here and light will enter in your eye. Now while traveling this path, the violet light being of smaller wavelength, it will scatter more here. So violet light will be scattered over here, indigo will be scattered here, blue will be scattered here, green will be scattered, yellow will be scattered, and all this light will enter over here, and this will be observed by the people present over here. यहाँ पे जो लोग खड़े हैं उनको ये सब कलर दिखाई देंगे, ठीक है? But since you are present over here, you will be getting only red color because the distance is more. The light has to travel more distance. Light has to travel more distance. That's why first violet will scatter, then indigo, then blue, green, yellow, orange, and which will remain only red will remain. That's why the sun will also appear red. The portion of that atmosphere will also horizon portion of the atmosphere near horizon will also appear to be red, है ना? And this will happen during sunrise. Same will be happening during sunset also. सनसेट होते समय और सनराइज होते समय यही बात होगी, है ना? क्या होगा बोलो, लाइट को ज्यादा डिस्टेंस कवर करना पड़ रहा है. ज्यादा डिस्टेंस कवर करना है तो शुरुआत में वायलेट, बाद में इंडिगो, ब्लू, ग्रीन, येलो एंड फाइनली रेड कलर विल रीच टू द आई. So you will observe the color of the sun is also red and the horizon is also reddish because of this scattering of light. Have you understood? Now, when the sun is at your 12 noon, at your head, what will find that the sunlight will enter into the atmosphere. When the sunlight enters the atmosphere, it all suffers from some scattering. The first light will be scattered violet, then indigo, and finally you will be getting blue color. Violet, indigo will be scattered and will going there, and blue color will be entering in your eye. That's why the sky looks. That's why the sky looks bluish. है ना? So since this distance is less, violet, indigo will vanish while coming towards you. It will be scattered earlier, and blue color will reach to eye. That's why this portion of the sky will appear bluish in color. है ना? Here the distance is more. So violet, indigo, blue, green, yellow, orange, red will be vanishing earlier, and red will reach to eye. That's why sun as well as the portion of the atmosphere will appear red. Okay, here distance is less. That's why violet, indigo will be scattered and blue will reach to you. Okay. Now, when the light from the sun comes to you, very few violet and indigo will be scattered, and rest of the light will reach to the eye, and all the colors will combine, and you will see that the sun is appearing white. So when the midday, when you observe the sun in midday time, what you find that sun appears white because all the 7 colors enter your eye, and after combining of 7 colors it will become white. So this way you can explain why the sun and atmosphere is reddish during sunrise and sunset, and why the sky is blue. Now assume that the sky atmosphere is absent. If the atmosphere is absent, this phenomenon will not occur. Scattering of light will not take place. So in that case, the sky will appear dark, black. You know, if the aeroplane is flying at higher altitudes, then also the scattering phenomenon will be not significant, and then also the person will see that sky is black. So aeroplane flying at larger height, the passenger inside the aeroplane will see that the sky is looking black because this phenomenon will not occur. Scattering of light will not occur. So this way, sunrise and sunset will give reddish color because of scattering of light, and midday you will observe that bluish color of the sky because of scattering of light. So this will explain, the scattering of light can explain this phenomenon very perfectly. Okay, so today we have completed this chapter. One activity and donation of eye. These two minor part is left over. So tomorrow we will cover this, and Sunday there will be test. Be prepared for the test. Okay.